What is the relationship between data and information? When we open a weather app in the morning, we see many numbers. It shows things like a temperature of 3 degrees Celsius, humidity of 40%, a fine dust level of 85 micrograms per cubic meter, and a 60% chance of rain. But we do not go out to start our day carrying those numbers themselves. We read the numbers and think, I think I need a padded coat today, or it might rain, so I should take an umbrella with me. This is where the difference between data and information appears. Data are the values or records we obtain through observation and measurement. Information is what we get after we organize and interpret those data so that we can use them to make a choice. Even the same number becomes information the moment it helps us decide something. This becomes clearer when we think about weather forecasting. First, data such as temperature, humidity, wind direction, and air pressure are collected. Those data pass through models and calculations and become a forecast, such as, it will rain in the afternoon. That forecast then becomes the starting point for our next choices, such as what we wear, how many umbrellas are sold, or when farmers plant their crops. In other words, data become information, and information can become data again for the next decision. When the person using it and the purpose change, the same content can be data or information. Then what forms can data take? Data can be divided into numerical data and categorical data according to their nature. Numerical data include values such as 50 people or 65 kilograms, where numbers describe a measurable size. However, not all numerical data are the same kind of number. Values that we can count, such as the number of people, products, or events, are called discrete data. There are clear gaps between the values. On the other hand, values such as time, length, and weight can include endlessly finer measurements within a range. These are called continuous data. There is no break between the values. Both types are expressed with numbers, but it helps to remember that some numbers count while others measure. When we understand this difference, we can understand data much more accurately. Categorical data include things such as blood type, gender, grade level, place of residence, and preferences. They are divided into categories. But even here, not all categories are the same. When there is no order between the categories, such as blood type or hometown, they are called nominal data. We cannot say that blood type A is bigger than type B, or that New York City is higher than London. On the other hand, when the categories have an order, such as satisfaction levels, ratings, or age groups, they are called ordinal data. Very good, good, average, poor clearly follows an order, and teens, 20s, 30s also has a clear sequence. We often attach numbers to categorical data. For example, labeling male as 1 and female as 2 can make organizing easier. However, we should not add or subtract those numbers as if they were numerical data. Those numbers are only labels, and they often do not represent size. These days, we also divide data according to how they are stored. Data with fixed spaces, like a table, which are easy to search, count, and update, are called structured data. In contrast, data such as text, photos, audio, and video do not have a consistent form and are called unstructured data. Unstructured data can be harder to handle, but that does not mean they cannot be analyzed. It simply means they are harder to calculate directly like a table. That is why, today, we use artificial intelligence and big data technology to find patterns and draw meaning from these kinds of data. However, there is one important thing we must remember. Information does not come from any data. Rumors or guesses might sound believable, but if the supporting data are unclear, it is difficult to call them information. Information fundamentally requires accuracy and reliability. Information also has different characteristics. Some information, such as earthquake alerts or typhoon warnings, becomes more valuable the more widely and quickly it spreads. This type of information has public value. Other information, such as stock investments or competitive strategies, becomes more valuable when fewer people have it first. This type of information has scarcity. The same information can look completely different depending on its purpose. That is why sometimes we need to think about ethics and rules as well. The value of information also does not stay the same forever. As time passes, its value often fades. Yesterday's traffic information or last month's price information rarely guides the decisions we make today. That is why good information needs not only accuracy and reliability, but also timeliness. If the cost of creating information becomes too large, it is difficult to sustain, so economic efficiency is also important. Information should also be useful in many different situations rather than being used only once. For that reason, usability is important as well. Good information is not simply something that is correct. It is something we can use at the moment we need it. Data are traces of our observations of the world. Information is the language of choice we draw from those traces. Data are the beginning. Information is direction. Think about one number you encountered today. Is that number simply staying as a record, or is it becoming information that guides your choices?